In this video, we'll go over all of the steps needed to configure alarms in Status Enterprise. This video will also cover how to use the alarm control as well, since alarming and the alarm control work very closely together. Alarms are an important part of every SCADA and HMI system. Without them, you're left in the dark should something happen in your process. By being able to properly monitor alarms and events, you can prevent costly repairs and keep your system running in top form. The first step is to create an alarm. But before we do that, we need to talk about where they're created and why. Alarms are defined at a type level, and since Status Enterprise as a whole is very focused on types and their reusability, it only makes sense that alarming follows suit. For example, in this demo we're looking at, we have a wind turbine type. If we click on this and then look at the properties, we can see that this type would be reused heavily in a real-world scenario. Now, if we expand the wind turbine parts, we'll see a bunch of different pieces of machinery that the turbine would use as components or pieces of itself. Given the nature of wind farms, where there's hundreds of turbines in an installation, it begins to make sense as to why we define our alarms at this level. This allows these alarms to be created on any assets that get generated from this type. Now that we have a better understanding of where alarms should be created, let's work on making one now. The first alarm I'm going to create is going to be on the rotor, so I'm going to select that from my wind turbine parts, then select RPM for the property. Next, I'll come down to the alarm section and click the Add Alarm button. This is where you'll select an alarm type and give your alarm a name. For this demonstration, I won't go into detail on the specifics of each type of alarm, but you can read more about these in the Status Enterprise User Guide in Section 9 on page 3. This comes installed with Status Enterprise and can also be found on our website. For this demo, the turbines need to report when the speeds are getting high, not just when they shut down. Because of this, the level alarm type is the option we'll be using, so I'm going to select that from my list. For the name, I'll give this alarm a name of RPM limit. Now I'll click OK to add it to our type. Now that we've added our alarm, we need to change the limits on it so it'll fall in line with the limits set on the property. The first thing I'll do is edit the low attribute and set it to 3. Next, I'll edit the high attribute and set it to 20. And then I'll set the high to 30. You can also configure the messages that get displayed when an alarm is generated. If you look at the low text, you'll see there's a placeholder for the alarm name in the message. These messages should be set to something that's clear and concise in a real-world scenario, but for this demonstration I'm just going to leave them as is. I also want to touch on the other attributes of the alarm as well. In addition to allowing custom messages, you have the option of setting the modeling rule. This allows you to specify whether this alarm will be created automatically on any asset that gets generated from this type or not. You can also enforce an acknowledgement requirement as well, and then you can either enable or disable this alarm by clicking the checkbox. Now that we've configured our limits, we need to create this alarm on the asset itself, so I'm going to switch to the Assets tab. Next, I'll find the rotor component of the TB1001 asset and select it. Then I'll select the RPM property, and we're now ready to add the alarm we configured earlier. To add your alarm, click the Create button to add it. Now that the alarm is added to this asset, it will trigger should the value breach any of the limits set. To demonstrate this, I'm going to open the model browser so we can look at our alarm functioning. I'll click the Connect button and wait for it to log in. Next, I'm going to browse for the rotor that we created the alarm on. I'll select it from the list, and then I'll click on the Alarms tab. Then I'll double-click the Asset Alarms button, and this will give us the view for any alarms on this rotor. In order to see our alarm, we'll need to change the value, so I'm going to switch back to the Data Model Designer and change the RPM property to 21. Now if we switch back to the model designer, you'll see that our alarm is now active in our view. Here you can manage your alarms. You can do things like acknowledge them, add comments to them, or clear them to the list. To demonstrate this, I'll enter a comment for this alarm. I'll type in, "I've seen this" as the comment. Next, I'll select my alarm and click the Acknowledge button. You'll now see that the Acknowledge status has been changed to true, and my comment has been added to it. Another interesting feature of alarming in the model browser is that you can select a parent asset and then see any of the alarms on its children. For example, I'm going to close this view for the rotor. Now I'll select the TB1001 asset. Next, I'll double-click the Asset Alarms button to open that alarm view again, and you'll see that in addition to our RPM limit alarm, we've got another alarm coming from the gearbox component on this turbine. Now that we've looked at how to configure these alarms and view them, let's talk about the alarm control. The alarm control is like the alarming view we just looked at in the model browser, but allows you to add this to your mimics. Let's get started by opening the Mimic Designer. After I've logged in, I'm going to create a mimic so we can work with this control. I'll click the New File button, then enter the document name Alarming and click OK. In the toolbox, there's a grouping called Alarming. This is where you'll find the alarm control. I'm going to add this control to our mimic so we can configure it. Now, we'll need to create a data binding to this, but because of the nature of the control and how alarms work, you have to do this a little bit differently than you would other data bindings. Before we do that though, I'm going to save this mimic. I'm going to select my mimics view and then click the OK button. If you go to the Properties panel, there's a property called Setup. When you click it, a dialog will appear that lets you select an asset path. This asset path is what the control uses to determine what alarm should be displayed. There's also an option to make this alarm configuration relative, which allows you to configure the display for more advanced setups like templated documents. We don't need this for our demonstration, so I'll uncheck it. Going back to the asset path, let's click the button so we can get a better understanding of how this works. We're now looking at the Select Data Item dialog. This will let you browse through your model to select an asset. For our model, I'm going to use the rotor part of the TB1001 asset, so I'll browse for it in the model and then select it. Next, I'll click OK, and you'll see that our asset path is now set to the asset that we just selected. I'll click OK again, and now we're ready to begin viewing alarms in our control. I'll save our mimic, and then I'll click the Test Run button to view this in the Mimic Runtime client. As you can see, we've got the same view that we saw in our model browser in our Mimic thanks to the alarm control. We can do everything we did in the model browser here as well, as like acknowledging alarms, clearing the list, and adding comments to them. In closing, Status Enterprise is a powerful, easy-to-use tool that lets you design once and deploy multiple times. For more information about Status Enterprise and alarming, please visit us on the web at www.bscada.com.